So now we are in lesson 4.4. It's about graphical interpretation of the derivative. First part in this lesson, it will be about the maximum and minimum. You can also say the extrema, the turning points, the stationary points. If you look at this graph, guys, you can see that there is here a maximum, there is another maximum, and there is here a minimum. If you look at the graph, this maximum, I have another one higher than this point. So that's why this one I will call it the local maximum, and this one is the global. Why do we call this one as the global? Because this is the highest point on the graph. I don't have any other point higher than this point on the graph. But for the minimum here, I set it the local minimum. It's not a global minimum because this graph is not limited. It's unlimited. It go more down. So there is more points that are below this minimum. So I call this one local minimum. Now we will learn how to find the maximum and the minimum when I have a function. So the sign of f prime of x gives me the behavior of f first of all. Why? Because when I say f prime of x, and we saw that in the beginning of this lesson, it means I'm finding the slope. And we know that when you have a line, if the slope is positive of the line will rise. When plotting a line, if for example, I have y equal to x plus 4, the line will be increasing. If the slope is negative, the line will be decreasing. So, and that if the slope is equal to 0, I will have a horizontal line. So if I have y equal to 4, if I draw it, it's a horizontal line. So that's why f prime of x will precise the behavior of the function. So when f prime of x is equal to 0, in this case, as I said, as I'm saying the slope is 0, it means I have a horizontal tangent. How I will be able to have a horizontal tangent? So I need to have a maximum or a minimum. So first of all, to find the extremum or the stationary points of the graph, I need to do the derivative and I solve it equal to 0. And then when I study the sign of f prime of x, I can either study it by doing a table of sign or by taking points before and after the stationary point that I will get. I will be able to know where f prime is negative, where f prime is positive. And where f prime is negative, when the slope is negative, it means the function is decreasing. Where f prime is positive, the function is increasing. So let's do an example, guys. If I have the function f of x is equal to x4 minus 4x squared plus 1. So if I want to find the turning points, or all what we need to do first, we need to do the derivative. And I need to solve it equal to 0. So f prime of x is equal, so derivative, from the preceding lesson, it's 8x3 minus 8x. Then I solve it equal to 0. Every time I need to solve any expression equal to 0, I need to factorize it. So if I look at this expression, I have 8x as a common factor. So it's 8x factor of x squared minus 1. A product is equal to 0 when one of the factors is 0. So I have, this one gives me x0, and x squared minus 1 gives me x1 and x minus 1. It means I have here 3 turning points. So those could be maximums or minimum. Now we will see from the sign if those represent a maximum or the minimum. So for x equal to 0, y is 1, I will place it here to know what is the coordinate of the extrema. For x1, also I replace it in the expression, and y is minus 1, and for x minus 1, also y is minus 1. Now, how we will know what those 3 points represent, maximum or minimum? I have two methods, guys. Either I do the table of sign like we're doing it in the chapter, I think it was chapter 3. So you can make a table, you put 8x, and then I put here x squared minus 1. The roots are minus 1, 0, 1. 8x is 0 for 0. We have opposite, same. Those are the roots, same, opposite, same. And then I do minus times minus plus, minus times plus, minus, plus times plus minus. Either I will check the points. What does it mean? I have this is f prime of x equal to 0 for minus 1, 0, and 1. I will take a point less than minus 1. Here I took minus 2, for example. I replace it in f prime of x, and I will see the sign. It gives me here minus 48. It means here it's negative. Then you take any point between minus 1 and 0. For example, you can have minus 0.5. It will give me a positive answer. Then you take any point between 0 and 1. For example, 0.5. It will give you a negative answer. And any point bigger than 1 will give you a positive answer. So when I say f prime of x is negative, it means f is decreasing and then increasing, decreasing, increasing. So now I can precise also the nature of this extreme. When I'm decreasing, so minus 1 will represent a minimum. 0, 1, it's a maximum. 1 minus 1 is a minimum. And then you can graph it. So you plot the extremum here, if you see it on the graph, and then I can see it from the table. Look, it's decrease, increase, decreasing. So I need to see this behavior on the graph. So I can see that I have two global minimum. I have the minus 1 and 1 minus 1, and I have a local maximum 0, 0 because I have here points higher than this point. Let's move now to part 2. What is the interpretation of the second derivative f double of x? Why sometimes we need to do the second derivative? The second derivative helps me to find the concavity of the function. And also it helps me to find something called inflection point. First of all, if you do, for example, f prime of a point, and the answer is 0, it means I know that at this point, I have it's concave up or it's a minimum. So also, sometimes if you have the extreme, you got it, and you want to check if this is an extreme, a maximum or a minimum, you can use the f prime instead of doing the table. So for example, if I got 2 is a minimum, is a extremum, okay? It's a stationary point. I do f double of 2. If the answer is positive, it means the function is concave up. It means, remember, up, there is a u, so it's u shape, so it means there is a minimum. If f double of x is negative, it means it's concave down, so I have a maximum. But if f double of x is 0, it may give me an inflection point. It's not all the time an inflection point. I will tell you why. What does mean inflection point means? It's S. I have S shape. But it could be concave down, then concave up, or concave up, then concave down. In this case, to know the concavity, we study the sign of f double of x before and after the inflection point. So, for example, if the inflection point is at 1, I do f prime of, for example, 0.5, double of 0.5 and the double of 1.5. So if f double of 0.5 is positive, it means it's gonna be concave up like this, and if it's negative, concave. But sometimes, guys, you can solve f double of x equal to 0. It will give you a solution, but it will not be an inflection point. How? For example, if this is f double of x, if you solve it equal to 0, it gives me x equal to 0. Now, if you take a point before 0, for example, minus 1, if you replace it, it gives me a positive answer. And if you take f double of 1, also it gives me a positive answer. So it cannot be an inflection point and there is no change in the sign, because I said an inflection point before it should be, for example, concave, then concave up, then concave down, or it's going to be concave down, then concave up. So if the sign is not changing, so I don't have this concavity, it means this point is not an inflection point. So it means that not every time I have double of x equal to 0, it is an inflection point. I need to check if there is a change in the sign. If there is no change in the sign, it means there is no inflection point. Guys, let's do an example to understand this part more. So I have f of x equal x4 plus 2x3. Find the turning point and the point of inflection of this function. Okay. If I want to find the turning point, means I want to find the stationary point, I do the derivative and then I solve it equal to 0. f prime of x gives me 4x3 plus 6x squared. You factorize, common factor x squared. So this one gives me 2 x or two turning points, x equal to 0 and x equal minus 3 over 2. So I have 0, 0 and minus 3 over 2, 153 over 16. I replaced those here to get the y, okay? Now, what is the nature of those turning points? Are those maximum or minimum? So I can do it instead of doing, for example, the table of sign like I did in part 1. I can do f double of 0. And I see if f double of 0 is positive, it means it's concave up. So it means it's a minimum. And if it's negative, concave down, so it's a maximum. So I will do f double of x first, and then I will replace by 0 and by minus 3 over 2. F double of x gives me, I'll look here, 12x squared plus 12x. And then I will do f double of 0 and f double of minus 3 over 2. If I do f double of 0, guys, I want to see if it's an inflection point, yes or no. So I need to see if we have a change here in the sign before and after 0, 0. So what you will do, guys, you'll do f double of minus 0.5 and f double of 1 because I took a number less than 0 and bigger than 0. F double of minus 0.5 gives me minus 3. It's negative. F double of 1 gives me positive. So yes, there is a change of sign. So before the 0, I have the F double is negative, so it means I have a concavity down. So concave down like it's here, and after it's concave up. So I got that 0, 0, it's an inflection point. It's not just one of the equinox, it's an inflection point. Now, if I want to check f double of minus 3 over 2, I got it positive, so it means it's concave up. So it means that this one is a minimum. So sometimes when you're checking uh, um, a stationary point, and if you got f double 0, it means it might be an inflection point. It's not just a stationary point. So by checking here, I discovered that 0 is also an inflection point. And now when I will try to find the remaining inflection points, you will see, guys, that 0 is there. So if I do now f double of x equal to 0, if I want to solve it, you factorize. Look, this is the first inflection point that I got it before. The second one is x equal minus 1. Now I want to check, is it really an inflection point or not? I will take, I will do f double of a point before minus 1 less, so it's minus 2, it gives me positive. So it's going to be concave up first, and then I find that f double of my 0.5 gives me negative. It means it's concave down, so this is an inflection point. So I repeat again this idea. So to check that first the turning point is a minimum or a maximum, I do f dub. I can either do the table of sign and see if the function is, and I could do like this here, this one, what I did here, and I can see why it's not going here. It's if it's decreasing and increasing, so I know if it's minimum or a maximum. Or also this point, I can check if it's a minimum or a maximum by doing f double of this point. If it gives me a positive answer, it means it's concave up. It means it's a minimum, and it gives me a negative answer, concave down. It's a maximum. But sometimes when you are checking the concavity of this point, if it gives me 0, it means it might be an inflection point. Sure, we will do more application in the class. I will leave part 3 and part 4 in the other video I will record.